Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on my virtual machine. So, I did a little bit since last stream, so let's take a look at what I did. So basically, now we have a new test in here. Let's see if I can find it. Int to stir, alright? So actually, let me do a git clean, and then I'll build it. Alright, and then int to stir dot tasm. We import the standard definitions, and then we push a new line as a stir, and then we push a number, and this is the number that we're going to convert to a string. And then we call into stir, which then takes this number and then converts it to a string and pushes the string onto the stack, or at least the pointer to the string. And then we push standard out and we write it, and that will write the number to the output. And then we also print a new line because the number doesn't have a new line. So yeah, this is just getting the new line string, push standard out, and write. So if we run that, there we go, 420. So that is the number that we put in there, and we can actually change it to 419, and then do the same thing. Whoops. And 419. So you can see it works as expected. So that is pretty cool stuff. That one. Alright, so what I want to do, right now at least, is try to get Fibonacci working using the same system. So right now we have the fib.tasm, and if we run that, you can see it prints it out, but it uses the print, which just prints, it doesn't know what the type is, so it prints all this stuff. So we get the pointer, the integer, as well as the float representation of it. So that is not very good, right? What I would rather have is it just prints the number. So we can do that now. So let's see. Maybe I'll show how it's implemented first, and then we can figure that out. So in tim.c, it is a native rather than a new instruction. So right here we have int to stir, and it's a little complicated because it actually we use that. I guess probably don't need to do that, and could just yeah, actually that's not necessary, so let me clean this up and it'll be a bit easier to read. So just do that and get rid of any of these things. Yeah, new, we don't need to function to it, and it should still work after doing this, hopefully, at least. Yeah, so then stir index, so that needs to be a pointer. Yeah, because we don't actually need to modify it like that. And then down here where we actually call it, we can not pass it as a pointer. Let me write that, and then make sure it still works. Let's see, so it is, oh, I have to get them in here. And there we go. Alright, yeah, so that is a bit better, I think. Yeah. Something else. Well, actually, I'll go over how it works, and then I will talk about that. So, basically, I kind of took it from Stack Overflow and then modified it to work for my purposes. If it's less than 0, which we don't have the ability to do that in the assembly right now, the virtual machine fully could support that. But the assembly, we don't have negative. Should get around to that eventually. But basically, we have this. Yeah, so this is just setting the stir index to the minus character, for the negative number, of course. And then we set it to the non-negative representation. Here we check if it's greater than 9. If it is, we divide it by 10, right? So if it's 100, it'll become 10, right? Something like that. And then we call it again on the new number. So basically what would happen there is when we come down here, so yeah, say it's 100 again, or say it's 10, that's maybe a bit easier. If it is 10, then it will first go through here, and the new one will be 1. So then it'll come down here, and this is just a fancy thing to convert anything from 0 to 9 into ASCII form. So basically, if 10 comes here, actually if 1 is here, it'll print 1, or append 1 at least. And then, if it is if it's something like 10, then it'll take the last digit. So in this case, 0. So the 1 goes through, it prints 1, and then it'll print 0, or append 0. So that's basically how this works, and we just iterate the index, yeah, all that. And then in here, here we pop it off as an int, and then we initialize the string index. And then here's the string, which we just allocate an arbitrary size. So maybe we should do that in the, like this malloc, maybe it should be done in the, on the stack, like using, we'll figure that out. Right now, yeah, just arbitrary size, into string, which is just that function that we're looking at. And then we put the null termination character, and then we push the pointer to the stack. Something I would like to do is actually make this native, so that it's something like that. Int to ASCII, essentially is what that means. They don't have that. It's not like a standard. Hello there, Bob Ross RTX. How are you doing? It's not a standard, so that's why I didn't use it. Like I don't think it's in Linux or whatever. But this is essentially what that is. So we can just call it that. Doing pretty good. Glad to hear that. Yeah, so we'll just use this and we'll pass the machine in there, and then we can do all this stuff in there. Because then it sort of is more standard with the. Apart from the fact that I hate CSS and web design, I know what you mean. I never really understood CSS, and I'm not a fan. Yeah. So let me just grab this, and then we'll make native iota, or it's not iota. It looks like that, so I read it as that. So yeah, actually, down here, native, that. There we go. Machine, and then I'll paste all this stuff in. Functionality overlooks. Yes, that's how. Basically everything I've ever made. I don't think I've ever made anything that actually looks nice. Yeah, like any UI based thing. Yeah. So this should work now. Hopefully. So now if I come down here, actually it should, if I build this, yeah, let me try that. So Tasm, test /, it is this one. Into stir, as there we go. And it works. Okay, so that is good. And then this can just kind of, this isn't really a native function anymore. So I'll just put it up here with all these other helper functions, if you will. Yeah, so that's pretty good now. And it is a bit cleaner because, well, this at least looks a lot cleaner. There's probably a better way to do this than a switch statement, so I'll look into that. But yeah, so now I will try to get the Fibonacci working. Yeah, so basically right now the Fibonacci, it looks like this. And I want it to just print the int value. So that's kind of what I am working on right now. So here it is. The n is the number of iterations. Yeah, so basically, here's where we print it. So we know at the top of the stack that is the number. So we need to duplicate it. And then call int to stir, which is actually, which is in the input standard deps Python type dot cache. Yeah, so we can import that. We call int to stir on that, and then we can push standard out and then change this to right, and that might be all that we have to do if I did everything correctly. Okay, and clearly I did not. Okay. Yeah, so I'm not sure. We print this now. What happens? Yeah, so it does that. So when we print it, it does that. But when we do int to stir, it doesn't work. So if we do int to stir and we print, alright, so it breaks when we do that. Okay. So did I actually confuse the, let's look at that one that we were just doing. So I forget what it's called. Int to stir, yeah. So we push the number and we call int to stir. So that should be fine, I think. Yeah, so I'm not sure why it wouldn't work. So that is what needs to be found out. Yeah. So fib.chasm. So yeah, that just prints 0 because we duplicated it. So we have to actually, whoops, have to get rid of that. And then this is how it was before. So actually, we do want to consume it. So I think we can just, I think that's what broke it up. If we do that, no, alright, yeah, because I didn't actually int to stir. Got to actually call what I'm doing here. And we don't have a new line. So up here, I'll just kind of, after the definitions, we'll just do push stir, push the new line. And then, yeah, here, we'll get stir 0, which is the new line. And then push standard out and right. There we go. Okay, cannot jump out of bounds. So, I don't know why it would say that. Yeah, that is interesting. So it looks like it works. It's gonna, yeah. Stack Overflow. That makes sense. So that is tad interesting. So once it reaches the end, it thinks it's jumping out of bounds. So why is that? But then, oh shoot. Yeah. Then if this is just like that, and we just do print, and it doesn't. It still does, okay. So it has something to do with the push string, I assume. I think it's 30 again. Yeah, so if I get rid of the push string. Yeah, okay. So it doesn't like that. Uh-huh. That's interesting. Why would that cause that? Not sure. What if I move it down here? Like, push stir, right there. It does it again. Okay, so it doesn't matter where we put it. So let's try to debug what would cause that. Because it is working now. Other than that. So the jump loop, and so let's see. It is the end jump that thinks is out of bounds. And I think I know what the issue is, actually. In the Pagina.c, when we encounter this one, we don't actually set the instruction. So we just want to push a nope instruction. So set the instruction type to not. So I think we can do this. Basically just do instruction type equals equals, how do you, let's see, how are we setting the type? Equal, yeah, inst, and then type no. Well, actually, we can just do inst no, like that. Now, and there we go. All right, yeah. So there was one instruction off, and that was causing it to think it was out of bounds. So now this works. This is Fibonacci, and we can modify it by changing this number to print basically as many as we want, other than like up to a certain limit, of course. But oops, yeah, there we go. Yeah, so you can see this all the way here. These are Fibonacci numbers or whatever. We could probably print the iteration as well. I don't know if that's a good idea. Because that might look nice, you know? So if I push sir colon space probably. Basically, we can print the iteration here. I guess we don't really have it here. Yeah, and what if we make this this, and then iteration, and then the iteration, so we can do it afterward, because that might be a bit simpler. So push one sub, yeah, so this is subtracting from the iteration. So here, after this, we have the iteration. So let's actually dupe it, and then do int to stir, push standard out, and then right, and actually right up here we can do get stir 1, and then push standard out and right. So yeah, so almost worked. Not quite. Oh yeah, because we do print the new line. So we want to do that actually at the end. So let me do that, and do that right here actually. There we go. All right. So this is, yeah, it actually counts down. So that's not good. So perhaps if we subtract, yeah, actually I'm not sure. So we basically need to reverse this, right? Because this is the 3 iteration 0, really. So we need it to count the other way. So we would need to change this. Yeah, I mean, well, that's good enough. Like, you get the idea at least. Yeah, maybe not ideal, but it works. And I feel like it'd just be kind of complicated to change it. But yeah, so let's change back to 30, because that's a good number. And I forgot to recompile it. And there we go. Yeah, so that's pretty good, I think. Maybe at the end we just want to print the number of iterations. Maybe that would look better. So if we do number of iterations, and then we get rid of, let's see, so we can actually leave that there, but we want to do that, get rid of that stuff, and then yeah, so that should still work. Yeah. Oh. Oh yeah, cool. So right here we are. Yeah, so we want to do that right at the top. So with just the N. Actually, no, I don't think that works. All right, yeah. So right here we can basically do. Well, we can do this right here. So get stir 1, write that, and then we can do into stir, push standard out, and right. Just in here, and that should print N, I think, if I did everything correctly. Alright, and then it stops after that, because I didn't actually do it. Alright, yeah, so maybe, now I'm thinking maybe this would be better to print at the end. Like, so, when we jump to end, put that in there, and we can push end. Yeah, something like that. And then we also want the new line, so we can do this, this same thing right here. And yeah, there we go. So, number of iterations. So yeah, then we can see how many we went through. Yeah, so we don't need to dupe N there. Undeclared label Q. Alright, that was weird, but there we go. Yeah, so now, yeah, what does that mean? Where is the Q at? Alright, so that's good then. I'm not sure what that was about, but must have been like an invisible character or something. Yeah, so now this is the end. And it works. So then we can see the number of iterations, and these are the numbers. So that's pretty cool. Yes, I do quite like that. So let me just updated Fibonacci to use int to stir to print the numbers. Int to stir and write to output the numbers. Yeah, so now we aren't relying on the print, which is just for debug purposes, really. And I don't think any of these actually use print anymore. Well, that's not true, actually. Yeah, some of them do. Do I want to update them now? Maybe not. So let's take a look now. So that is there. There's reverse string. And I think we can add more modes here. So these are like the opening files. It'd be pretty easy. I'm pretty sure all we have to do is this. Update these two things. So Metame is rated with a party of 8. Thank you. I appreciate that. Very cool. Hello, everybody. Welcome, welcome. Working on a virtual machine right now. Virtual machine, yes. So hello, everybody. Hello, indeed. Okay, yeah. So we're using C here. So I just updated using my custom assembly. This now are my let's see, Fibonacci numbers. Printing them out. We can actually do that now using this, and it prints it out in the number of iterations, just like this. So that's pretty cool. That's what I have been working on. Yes. So now I'm not sure. I might work more on the assembly, like writing in it, or I might update something else. So I'm gonna kind of look at what we've got. Yeah. Okay, so something I was looking at was when we open the files, these are the only modes that we can use right now. But that is not ideal. So I think I will add a couple more. Yeah. Does that one work? Maybe. So now, how many is that? So that's 6 then. So yeah, we need to make sure that that works. And then, is that the right symbol for it? I don't remember. So let me do C open file, CF open rather. That is what I'm going to be looking at. Yeah, so here's all the modes. Doesn't include the byte ones though, which is quite important, especially when you're working with bytecode. Yeah, so empty file. Okay. Yeah, so we don't have a pen either. Probably should add that as well. But I just want to see all the different modes possible. Does this have... Yes, this does have that. So, okay. Pop-ups. Yeah, so we have read, write. And I suppose this is... Yeah, well, so maybe we don't need this one. And then should I add a pen? That's probably a good idea. And then a pen bytes as well. Whoops. Now it's too small. Alright, there we go. Yeah, so we will pen byte. There we go. So now we have 7 of these. And hopefully they all work. And I do see a missing comma. And let's make sure it compiles still. Yep. Alright, so now we should be able to use those. And then the index is based on... The index is what mode you want to write in, or what you want to open it with. Yeah. So, let's see. So that was something that I've been meaning to do. And now, let's see. So we have recently added string support. So I can show an example of that. If we compile hello world. Hello world, so that's how it works. Showing how it works, here is the assembly for it. So we import this, which just has some definitions in it, some macros. And that is my own preprocessor that I actually built on stream for this specifically. And then this pushes a string to the string stack. In this case, it's hello world. and then we can get the string, which pushes it to the instruction stack. Well, not the instruction stack, the other stack, the main stack, essentially, the memory stack. And this is the mode that you want to, the file that you want to write to, so standard out, and this write, and it will just automatically infer the length of it based, because it's null terminated. So, yeah, so if you change it to be like that, then it will cut off there. Yeah, you can see there. Which that's how it works in C as well, so I think it's fine to do that. Yeah, so basically, I think I can make like FizzBuzz, something like that. Shouldn't be too hard. Yeah, so if we just push the strings initially, because you can push them anywhere and they're accessible, because they're actually stored in the bytecode. So we could have fizz and buzz, and then we can push 100. So that is the iterations, and we'll descend from there. I actually want to start at 1. Start at 1, and then we'll compare 100. So this will be the end. And then jump 0. So if it is actually not 0 jump, that's what we want to do. So if it is not 0, then that means this was true. So we can jump to end. So we'll make an end. Yeah. End, and then here we can just end. So we can exit, I suppose. So push 0 and exit. Yes, so then here's where the actual logic will go. So I think we can make a loop here. And then here we can do jump loop. If we do not jump to end, we'll jump to the loop. And let's see. So we need to use the mod operator. So basically we'll push 3. Push 3. Yeah, actually we need to duplicate. So this will duplicate 1 on the top of the stack. And then push 3. And then we need to do mod. And then compare equal to 0. And so up here we can actually have handle maybe up here instead. Yeah. So let's see. So here's the main one. So we'll jump to main because we don't actually have a starting point. So that's kind of how we have to do that. Actually, I will also import standard defs because I feel like those would be useful here. Yeah, so this can be handle 3. So compare equals 0. And then not 0 jump to handle 3. So I probably won't do this right on the first try. Yeah, but if it is 0, then we want to print fizz. So we can get sir 0 and then push standard out and then right. And I think that is all that we need there. And then yeah, so this we can do basically the same thing for handle 5, except the first string instead. So I think that'll work. So yeah, then we can. So this one will consume. Well, this consume both of those. So I think I need to do. And then let's see. Yeah, basically do the same thing here. Mod compare equals 0. Handle 5. And then I guess we need some way to do an else. Yeah, well, let's see actually if this will even work at all. So let's try that. Yeah, so something did not work at all. What would that be? This is an assert failed. So I think there's something wrong in the logic of the actual assembler. So let me debug that. I can't actually open that from here, so I need to exit here. So we can actually look. So here we have the assert. So this is the one that failed, I believe. So we can actually print f head value dot type. Actually, I think we can print it as a string if we do this. This is a function that we have for printing these. And I think that'll work. So, build it. And that didn't work. And this needs to actually be a token. So we can just do that. And let's see, that one actually works. We need token equals that. Type equals head value dot type. And yeah, we can do that in here. Type, just like that. Unused variable token. Yeah, no, I wanted to pass token in here, not type. And I forgot a semicolon. And then, alright, other things broke. So this needs to, there we go. Okay. Now, we should be able to see, where it's actually found. So, yeah, right here. So int, build on int. So why would that be? Because we have, well, the formatting is kind of messed up in here, but we do have int in here. So I am not sure what that is about. I'm not sure how this got so messed up either. Alright, there we go. Alright, so so yeah, why do we shouldn't encounter it? So I think I must have messed something up. Actually already in there. So let's look at FizzBuzz. So it was compare equal. So did I do that wrong? Yes, actually I need to push 0. So that is also a problem in the parser. Apparently, on the compare, we don't check. Yeah. So that is something that I need to keep a note of, but that is essentially the issue. Is that this was supposed to be push 0, and then compare. And then 100 as well. And here as well. So, yeah, cp test, tasm, FizzBuzz.tasm. Alright. Tired, FizzBuzz.tim. Buzz. Alright, so it's not exactly the intended behavior. Let me see if I can. I want to get rid of that print statement that we have in here, as well as that. Okay, just because that was kind of annoying. Alright, so why does it print buzz every time? So I might have messed something up in the logic. So if it's equal, yeah. So that should be fine, I think. But it seems to be doing that every time. And then Stack Overflow is what happens. Just like the website. So actually the second one is always true because we're doing buzz. So 5 mod 0 compare equal. So does this not actually consume all of these? That could be an issue. So we duplicate it. So we have 1 and 1 on the stack. 1 and 1. And then we push 3, so we have 3 on the stack, and then we mod, and then that returns whatever the value is. So yeah, whoops, whatever the value is, and then we push 0, and then we compare them, and then yeah, okay, and then we actually, so not 0 jump. Let me look at how that's implemented. So I don't know that it actually consumes the character. Hold on. So actually, so does it not? Let me try that. Yeah, so it... Alright, now this doesn't... Whoops, I actually... Not zero. So why does it not work now? It was just working a second ago. Oh, it's because of these right here. Yeah, so let me try that again. So we have this, so pop, and then $5.10. Alright, yeah, so that doesn't work. Stack overflow is what we encountered. Oh, because we never actually subtract from the loop. So yeah, so basically we want to, here we just want to push 1 and then sub. Alright, so it still does that, because I think that we need to pop here. Nope. Alright, so why is that? Yeah, so let me follow the logic again. So then we have 1 on the stack. Let me open up a new one here. So we have 1 on the stack. I zoom in here. Not ls. There we go. Alright, 1 on the stack. And then we have another one. And we have 3. And we mod it. So then that returns the value. And then we push 0. We compare them. Not 0 jump. Yeah. So then we do pop this off. Then we duplicate this again. Push 5, do the same thing. And it returns the value. Or it pushes the value rather. And then push 0, and we compare them. And then we do that, and we pop it. And then we push 1, and we subtract. I actually want to add though. Yeah, it still doesn't work, but so I think we can, let's print the stack on each iteration, and then we'll be able to see what's happening. So if we do this again, that's what it does. So yeah, the stack, I think, oh shoot, that actually printed quite a bit. Exit that. Yeah, so actually, yeah, so that was 10,000 just from that. So that is interesting. So we aren't removing something from the stack. So I suppose that is probably here. Maybe we need to pop right there. FizzBuzz Tim? No. So that doesn't work either. It's hard to keep track of it. I don't really have a good way of keeping track of that. I suppose in here though. Compare equal. No, in the jump. Not 0 jump. This one. We could print F. Now let's print the stack just on this iteration. And then we can see what's happening. Alright, it still prints way too many. So yeah, this is what the stack looks like. So we are pushing numbers and they are not getting handled. So does compare equal? Does that not pop it off properly? Compare equal, yeah. So it pops them both off. Oh, but then it pushes them back on. Oh, okay. So that is actually something that we need to account for. So that is a big part of our problem. So we want to actually pop it all off. Yeah, okay. So let's get rid of that. Get rid of that. So basically, it will, these two will be on here. So we might need to pop twice. And then after this one, pop and pop. Push 1, add. Push 100, and then compare. And pop twice. So let's see. FizzBuzz. Okay, so that was closer. So we printed out, or on the stack at least. Actually, let me get rid of the print stack. Because I don't want that anymore. Alright, so now let's try that again. Stack underflow. Okay, so this time we popped too many times. We can look at, this is what the stack looked like. No, so this was the stack. And 0, okay. And we pushed 100. Boom, boom. Okay. Maybe we just need to pop one time here. Okay. Yeah, so that is a bit closer. We did have a stack overflow, but then it continued printing. And that shouldn't happen because I'm pretty sure everywhere that we have stack overflow, it exits. So stack overflow. Yeah, so these three, and it exits on all of them. So I'm not sure why it would continue there, but we did print that out. And then let's print the number as well. So before we jump to the loop, we'll duplicate the number, and then we will do int to stir, and then push standard out, and then we will write. So I think that will work. Yeah, so let's also print a new line. So for now, I'm just gonna add it to these so that we can kind of see more what's happening. There we go. So 23. So it gets stuck at 23. There we go. Yeah, so it's stuck at 23, and that printed a lot of times. So I'm not sure why that would be. Yeah. There we go. So it starts at 23. And I don't know why that would be. Push 1, and then that. For this, actually, instead of this, I suppose we could do 0 then, right? And I think that actually consumes it, right? Inst z jump right here. Yeah, so I'm pretty sure this will consume it. So then we can just get rid of that entirely, and we can do the same thing down here. Then I think that we don't need the pops. So something like that. And let's see. Yeah, okay, so then that's the same behavior, but it is simpler. Yeah, so now push 100, compare. That will push, alright, so if it's true, then we'll jump to the end. Otherwise, we pop and then duplicate. Okay. Here we integer. So we are doing that on the wrong thing, it looks like. So I don't know where the 23 is coming from exactly. So let me just, for debug purposes, this is integer. Let me just print the stack. And then build that. Oops. There we go. And then we'll try that again. Okay. So, yeah. So that is the stack. So we do need to do something about that. Pop. So do we have to pop again? No. So then we get an underflow. 2 and 2. So that is on this one. So then we have another thing on the stack. And this pops out 2 of them. Yeah, then we pop the last one, so we don't want that. So we get 2 on the stack. So that is the right number. So into stir. So am I doing that right? Let me see. Slash but without into stir. So let me see. So yeah, so that should be working. So this prints the character on the top, but for some reason it doesn't. It's not working, I guess. Let me actually print what it pops out. So let me print X. So I'll just make it clear. I'll do that. And then oh yeah, so it's actually a long. Did I not save that? There we go. Okay. Only took 3 tries. And then here. Actually, this is the wrong one. There we go. Chasm, and then FizzBuzz. FizzBuzz 10. Alright. So X is 3. And then 2. Okay. So I think actually push the new line. And then I will print the new line at the end instead of this. So before we jump to the loop, we'll get stir. What string is this? So that is the second, number 2, and then push it out, and then right, and then that should FizzBuzz 10. Okay, so then let me get rid of this that I added up here, because that is making it confusing to read. Okay, so now we can see it a little bit better. So FizzBuzz, and then it prints 2 and a new line, and then it prints it again. So that's not So why does it print 2 and then another number? But so the number doesn't keep going up. So I think we can do something up here like iterate number, and then we can actually move that logic into here. So basically instead of this we can just do iterate number, and we want to actually jump to that. And then we can take this, and so whatever is at the top of the stack will be iterated. Yeah, so iterated by 1. Actually, after this we have to jump back. That's something I didn't consider. So actually it goes here and then it goes through all of this. Because we don't have like a return at the moment, so we can use jump. So basically continue can be defined there, and this can be 5 continue, and then here we can do continue. We want to jump, and here we want to jump to 5 continue, and then here we can jump to iterate continue. So let me do that here. So I completely forgot about that. Continue. Alright, so let me see what that does. Okay, so that is much closer to what I wanted. So actually, I think maybe it is not better to have that. Oh yeah. Oops. There we go. And now, yeah. So now this is closer. So there is no new line after either fizz or buzz. But yeah, so that's pretty close now. So what we can do is actually print new line after like right before the number, because that's never going to be next to each other. So we can do get stir to push standard out and then right, and that should do it. Almost did it. Now, yeah, so it writes a new line more times than we want. So actually, we might be able to just get rid of this one. Almost there. So now, let's see, what can I do about that? See, this is why you need like the else statement, essentially. So there is something else that, but let's make sure all the numbers are right at least. So we don't actually print 1, so that is strange. And then 2, and then 3, we print fizz. And then 4, 5, buzz, 6, and then on 15 we print FizzBuzz. So this is getting close. So actually this would be solved. Yeah, we just need to not print the number when either one of those is. Yeah, so what we can do actually, I think, is what is a good way to go about doing this? Basically, we can just jump to the loop right after this one. So let me see. Right after 5, the 5 one, where is that? Yeah, handle 5. The 5 continue can be moved to the after this. So actually, after where we print the number, but we still want to iterate it, I guess. So that might not work. But basically, yeah. So I think we need a variable, or not a variable really, but something on the stack, which basically indicates whether or not we have done either of these. So let's try to add that. So let's push 0. So it'll start at 0, and then we actually want to in swap with 0. And then that'll be this one, and then this will be on the bottom. So then in handle 5 we can do basically at the end we'll do in swap 0, and then we'll do push 1 and then add, and then we can in swap with 0 again. So that basically switches them around. We can do the same thing here. And then once we get down to where we actually print it, so this is into stir. Yeah, so once we are here, we want to actually, this dupe goes with that. Basically we'll in swap with 0 and then push 0. Actually, we can do not 0 jump. We need to duplicate it though. So actually, let's just do in dupe 0 and then 0 jump. Yeah, so if it's 0, then we want to print it. Otherwise, we want to do this. So not 0 jump, and we'll just jump right to the loop, I think. Otherwise, we continue on here. So let me try that. Okay, that's not quite right. So, because we don't actually switch it back, so that is quite important to do. Yeah, okay. So we might need to do 0 jump, and then we jump to handle number. Yeah, so let's just make handle number up here. Handle number, and then we can jump to number continue. This is getting a little complicated. Not too bad though. So yeah, here we can have number continue, the label, and then here we can take these and put them up here. So yeah, and we can just swap them. So right up here we need to swap them. Let's see. Yeah, I actually put these too low. We need to go right there, and yeah, we will do in swap 0. And I think, well, actually, so that should remove it, so it shouldn't exist after that, right? But we do, yeah, so that should be fine, actually. So I don't think we need that, do we? Uh, hmm. Yeah, so I'm not sure. Basically, so 0 is gonna be that one. So it should duplicate it. And then if it's 0, which pops it off, then we jump to handle number. Otherwise, otherwise we just continue. So, I'm not sure. I don't know. So let me try pop. Yeah, so that's not right. Yeah. So I think I'm going to have to kind of follow the logic again. So here we push 1 and push 0 and we swap them. So 0 and then 1. Then we duplicate it, push 3, mod, and then 0 jump. So it's not 0, but we pop it off. And then we just continue. Duplicate it, push 5, mod, and then 0 jump. So that, yeah, that just pops it off, basically. Yeah, so then we get that, but that doesn't matter because it gets removed immediately. Then we push 1, and we add, so it becomes 2. And then we push 100, and then we compare them, equal. Yeah, but then it doesn't pop either of them off, but then it gets popped off. Well, actually, not 0 jump. Pops one of them off, and then, is that right? Let me see, actually, where do I have that? Okay. So we do need to pop it. So this duplicates the 0th element, which should be that. And then 0 jump, we handle number. And that should remove that. And then duplicate this. Convert it to string, print it out, and then jump to number continue. And then jump to loop. So oh yeah, but we didn't want to actually get rid of that. So yeah, that's something I forgot. We don't want to leave this here. We push on each iteration because it changes. So this can be swap actually, I think. There we go. Okay, so FizzBuzz. Alright, so now it's not working as expected, but 3 fizz 4. So it doesn't print 4 there. Okay. So it doesn't print 98, even though that is not a multiple of 3 or 5. Okay. Fizz. Swap 0, push 1, add, and then swap it with 0. So that should be iterating it, right? Let me actually do dupe, and then int, and then continue. So 1, yeah, so it becomes 1. And then in here, it should be 1 or 2. Yeah, so that's fine. So then down here, actually in the handle number, or right before that rather, where we do this, let's print out what it is. Zero and then 1. So, okay. So 0, 0, 1, 1. So 1 means that we continue. Yeah, 1 means that we continue. So, continue without this. Okay. So then we print fizz after that, and we don't print a number. And then here, why is it 1 when we don't have, so that's 96, and 97, it should not be 1. So it's not getting reset properly. So, okay. So, do I have a stack? I'm not using that anymore. So let me just unprint. Let me, instead of just printing this, I'll just print the whole stack. Print stack chain. And then I'll be able to see a bit more of what is going on. I didn't actually rebuild it. There we go. And then, okay, so 0 and 99, 0, 98, 97. Yeah, okay. So now this is a bit more convenient because yay, just got my site deployed. That is cool to hear. Is it, so it's like public now? You can leave the link if you want to do that. I would like to check it out if you don't mind. If not, then that's cool, obviously. But yeah, so it shouldn't be 1 here on 94. So why is it? And then here it should, so we need to basically do the opposite of what we're doing, it looks like almost. Almost. Okay. Public indeed. Alright. Oh, it's for your website? Or for your program? Website for your programming language? Alright. Demi, upcoming programming language? Alright. Demi. Let's see. GitHub. Demiland. Only thing missing is the domain name. Insert. Yes. Domain name. Alright. Developed in TypeScript. Okay. It's not even compiled. Okay. Just rework the styling. So it's probably pretty slow though, right? If it's an interpreted language in TypeScript. I mean, I'm assuming. Alright, let's look. Hello equal hello world. So you can't just print strings directly. It needs to be a variable. Okay. Here's Fibonacci. Okay. Pretty standard. It's pretty fast. Oh, okay. It's pretty surprising, actually. Yeah, that's pretty cool stuff. So how far along are you with it? Like, how long have you been working on it? Yeah, Demi Lang. Simplicity and performance. Seamless coding experience. Okay. Far from being ready, but there are big plans. Okay. Yeah, this is pretty cool stuff. Deno. Oh, built. Okay, so it's not using Node. You can actually print strings directly. Oh, okay. Oh, but this is just to show off the variables, I suppose, as well as the print. Okay, that makes sense. Yeah. Alright, this is very cool stuff. Not Node Deno runtime. Yeah. So is Deno, I think that's how you pronounce it. Is that faster than Node? Like I'm not super familiar with JavaScript in that way, or TypeScript or whatever. Which is, yeah. So is it like a decent amount faster? Yeah, because I never really messed around with Deno at all. Yeah. Very cool stuff though. Very cool. So yeah, let me actually. Yeah, so then yeah, that obviously still doesn't work. But it seems like it's just randomized. Faster than node, yes. Oh, okay. So that is something I will check out and mess around with. I want to try compiling. Once I finish this, I might look at it on stream. Actually, I think that could be cool. I might need to install some stuff because I don't know that I have much JavaScript stuff installed. I haven't used JavaScript in a while. So this is not working. Basically, when we add it, for whatever reason, it doesn't work. Yeah. So let me actually go all the way up to the first ones. So yeah, and see where it sort of starts to fall apart. 2, and then yeah. So we don't print anything on 1 because we actually add to it first. So that is actually an issue. So let me change that. Down here, yeah. I actually want to move this. All this actually. I'm pretty sure. This. Yeah, can all just go down here. Yeah. Alright, so let me try that now. Alright, so it still didn't fix it, but now it should print 1. Because that's why it was not doing anything for 1 before. If I go all the way up here, actually I could do, there we go, that's better. Yeah, so now we get 1, and it actually prints out 1. And then 2, it prints fizz on 2, so that is not great. So why is that? So is it 1 off now? That is interesting. It says my stream is unstable, so I apologize if it is a little messed up. 4 buzz, yeah, so it seems to be 1 off now. That is interesting. So why would that happen? Oh, well, we do start at 1. But that shouldn't matter, actually. So I'm not sure why. 0 jump. We do this. So then we get the string, and we write it, and then we index swap with 0. Push 1, add to it. Yeah, that should be fine. And then put it back in the 0th place. And then continue. So I'm not sure why it would be off like that. Yeah, and then fizz. So that is number 5, but it thinks it's 6. At least in here it does. Let me see if I can actually let me dupe and then print. Right, there we go. So yeah. Whoops. Let me get rid of the other print that we have. Which was right here. And then we can see a bit more clearly. So 98. Yeah. So on number 98, it thinks it is which one was that at? Dupe and print. Yeah, so that's in 3. So it thinks it's a multiple of 3. So it prints fizz. 99. Okay. That is a tad strange. Let's see. So actually, this is the next one, right? Okay, let me just search in here. Print. Yes, that's the only print that I have. 95. So why is it? Alright. 2 is at the top. Okay, yeah, so it actually prints it every time. So I don't know what I was thinking exactly. But yeah, so when it's 0 at the top, so that's 99 actually, so that is fine. And then 98 is 2 at the top, 97, and 96 is 0. Okay. Alright, so that actually looks fine. Yeah, so it just doesn't print the numbers when we would want it to. Exactly. So where do we actually steer it to? Right, only right there after 5. So since we moved this up here, we could actually do it in there as well. And then there. Now it's all on a new line. 98, 97. Okay. 94. So, alright, and then let me grab this new line one. And then actually place it right there. Okay, so, alright. I think this is right actually now. So 1, 2, 3 is Fizz, 4, 5 is Buzz, and then 6 is Fizz, 7, 8, and then we get to 15, FizzBuzz. Okay, so then it worked. It worked. We do need one extra 100. So actually what we want to do is compare, what is it called? Compare less than or equal to, no, so just less than. Compare less. I think that is the right instruction. 99, and then 100 is, okay, yeah, there we go. So we printed the 100 FizzBuzz numbers, and this should work. Yeah, so actually if we just change, let me make a definition up here. N, and we'll do 100 by default. And then basically we'll just use that down here. So this is the number of iterations. And there we go. And so if we change N to 500, then it should print out that many. Yep, alright, up to 500. So that is pretty cool. Change to 5 as well. And only from the first 5. Yeah, so that seems to be working now. So now we have FizzBuzz in my custom assembly for my virtual machine. I think that is pretty cool. So leave it at 100 because that's kind of like the standard. And there's probably some good ways to clean this up a bit. Which is something I will work on off stream probably. Yeah, so let me actually push the changes. I don't think we really changed anything in the virtual machine, but we just added some, or not too much at least. So we did add the open stuff. That's sick, very sick. Yeah, so that was changed to the instruction formatting. Okay, so, oh yeah, you know what? I need to change something back before I do anything. Pin.c. So down here, yeah, this, we don't want to print the stack. Yeah, so now I can build this again. And I'll build all the tests, make sure they all still compile. So we'll try out bid.tim. Alright, so that works. Hello world. And then, of course, FizzBuzz. And it all works. Okay, so I will commit this. Implemented FizzBuzz in Chasm and cleaned up. Well, I didn't really clean anything up. And then, yeah, that's basically it. Yeah, implemented FizzBuzz in Chasm. There we go. So I will push that. There we go. So now I actually want to take a look at this demi-lang. So not working on virtual machine anymore. Yes. So I will change the stream title so it is not misleading. Alright, there we go. So now the stream title should more reflect what we are doing. So let me see. So Deno. So I need to install that. I'm going to do that on my second monitor. Because so I think I can use Pac-Man to do that. Yeah, alright. I am quite sure that will work. Yeah. So installing that, and then clone the repository. So let me grab this actually. So, and then, yeah, I'll just clone it right here. Git clone, I want that one. And then, that one. So I just want to get the most recent one. Yeah, yes. Okay, and damn it. Alright, so here it is, and let's do the compile. So finish compile. That's it. So I need to do that. And then winning. Okay. Value is required for. All right. So dash dash target. Do I have to do that? Compilation. All right. So kind of funny. It says compilation complete, but there's an error. It's kind of funny. So dash dash target target. Okay, I see. I have to actually read what this says. So x86 64. Hopefully it does work on here. Unknown Linux. Oh, all right. Do all. Okay. Module not found. Yeah. So main.ts. So it didn't. So there is no main.typescript. So that it should be in source though, right? Yeah, that's where it is. So let me look at that actually. So was this tested? Like, is it because I'm using Linux? Like, is that why it's trying to get it the wrong one, or pilot sh all? Yeah. So, yeah, it's not looking in the source. Can I just? Not too sure. Not really tested. Yeah. Okay. Well, I'm gonna see if I can figure it out. Yeah. So that is if platform equals Linux, then remove the old build. All right. Yeah. So. Alright, let me try that. Alright, yeah, so I changed that to source. And it looks like it is doing something at least. Yes. So I mean, I just modified it on the Linux one, so I still can't find it on these ones, but yeah, I'm not sure. So, let me see, did that work? So, alright, we have build, Linux, demi, okay. So let's run that. Alright, and let's try some stuff out. So it looks like it's working. Hello equal hello world. Oh, got it. It's semicolon, my bad. Right. Hello equal hello world semicolon. There we go. And then print hello. There we go. Okay. So the new line, just muscle memory, so I included that. Alright, you can't up and down, that's fine. Okay, so yeah, let me print hello world. Okay, I didn't put the semicolon again. Hello world. Semicolon. There we go. Alright, so that is pretty cool. So I'm assuming you can make a file as well. So is it just .demi is the expected extension? There is examples, so let's look at some of those. And I'm assuming you just do demi and then the file name, right? So I can try that. /build / linux / demi, and then examples / loop like that. All right, 1 2. All right, so it just runs it. Okay, yeah, it's interpreted, so of course. Okay, pretty cool stuff. So let's go into examples and we can look in here. So let me actually copy paste the build Linux demi through here, so I can just run it like this. Yeah, all right. So let's look at how. Let's look at the loop. Yeah. So I can just look in here. So there is not syntax highlighting. Obviously. Yes. So that is a thing. But that's okay. Maybe I'll look in here because it probably looks a little bit better in here. Unless it doesn't use it. Yeah, okay, so it looks the same. So that's fine. Yeah, so basically, here's the function. And then start equals get time. Okay, so you can run get time. So why is there a double semicolon? So do you have to do that sometimes, or how does that work exactly? Yes. In here, whoops. Yeah. Yeah, so I don't see any double semicolons here, but they are in here. So, yeah, just wondering about that. Current time equals get time. Okay. The moment double semicolons are for variables that are defined to function results. Okay. Okay. So let y equals 0, while y is less than x, y equals y plus 1, print y. Alright, yeah. So then sleep. So I'm gonna, let's see. So is this a comment? Or, let's see. It probably showed something. Yeah, hashtag, okay. Let me try that. And then I'll run demi on loop. Yeah. Okay, so yeah, so I just wanted to get rid of that because I was like, oh, it's kind of slow, but then because it has the sleep. So yeah, that is pretty fast. So let me find that actually. It's not very much. Yeah, all right, so let's try some more iterations. So yeah, 10 rather than 10, we'll do like 1,000. Yeah, okay. So that didn't take very long. That's pretty cool. Pretty cool stuff. Yay, the sleep function works. Yeah, even though I commented out. So, yeah. So that's pretty cool. Let's look at another example. So, strings. Let's look at strings. Okay, so, my string, okay, hello, demi world. I am string 2. Okay, so yeah. So, single quotes also are strings. So, that's a thing. Yeah. I like that for just characters, but that's just C stuff. Yeah, but that's fine. So my string and then test and test 2. So what is that? String. Yeah, so this one doesn't work unless I mess something up. Yeah, so it thinks that, so these are, cannot resolve them. So that works. What is with that? So is that how it is in here as well? In the strings examples. Where was that? Where was that at? Strings. Yeah, so it does have that. So I don't, yeah. So it doesn't work with those. You have to remove them. Yeah, so what else is there? Syntax test. Let's just look at that. If I can spell. Okay, I'm in string 2. Yep, so that's the same thing we saw there. Function test. Okay, print other strings. I think that one. Let x equals 10. To be fair, those examples are just thrown together, not really organized, but I plan on replacing all examples with tests and set up something. Alright, that makes sense. Yes, I understand. Yes. Wait, objects. So there is like classes, right? Okay, yeah. Pretty cool stuff. Alright, yeah. Well, I was doing it. So output equals null. Demi equals true. It is false. Yeah, okay. So null is what you initialize. So there's not, yeah. Classes to be added. Okay. And objects are currently broken. Alright, that's understandable. Yeah, so let me actually test. Oh yeah, here we have the objects down here that are broken, like you said. Okay, let me try this one. So what is the file that I'm in actually? This is just syntax test. Okay, so that all does work. So yeah, this is just like counting down. It's stimulate. Alright, so that is pretty cool. So let's look at another one. If statement. Yeah, so pretty standard if statement. Else print false. With an elif, okay, crazy elif. So like that, you can go as many as you want. Yes, a equals 0. Alright, yeah. So okay, yes. So that is pretty cool stuff. So let me actually run that one. Alright, so missing out. Oh yeah, so these don't have, I'm assuming that would be because you didn't originally have semicolons or something, and that's why this doesn't have that. Yeah, I don't know, but speculation. Yeah. Alright, so I would like to know the... I didn't actually do that here. The line number where it's at. Alright, there we go. So that works then. 7th element. Yep. Alright, so old examples. Yeah. So before semicolons, I'm assuming. Or something like that. So let's see, what else? Printing. So we saw most of that. So yeah, you can just print numbers like this. As well as, yeah. So that's pretty cool. Let me look at that. Actually, that doesn't have a semicolon, so... 7.5, okay, so that is cool. Actually, okay. 7.5, so... it doesn't print 45. So is that... Yeah, so all examples, right? Yeah, so I don't know what that is about, but time... get time, yeah. So, add that. So let me try running that. Okay, so that is the time. Alright, that is cool. Cool stuff. Alright, class.them. Yeah, so these aren't implemented yet. Alright. Random. So there is quite a bit of stuff to this language. Yeah, so that's pretty cool actually. So this is random stuff. Random range. And then is there the ability to include files as well? Like, you know, include or import or whatever. Is that a thing? I might be missing it, but let me see. That's a directory. Okay. Oh yeah, these are the ones from the README. Okay. Totally. Yeah. File. Okay, coming soon. Wait, where is it expecting semicolon? So this one might just not work anymore. After return statement. But they both do have those, so that's a bit interesting. So that one doesn't work. Let's try the Fibonacci. Whoops, it's // Okay, so that one works. Yeah, so let me see. Let's do the first 30. Okay, yep, so that is good. I have memorized, not actually, but I can recognize the Fibonacci numbers from messing around with it a lot in my assembly. Double semicolon on return statements. Oh, okay, so that is what the issue was. So let me just do that, like that, and okay. So, alright, there we go. So, undefined, no. Alright, so that looks like it works. Worked pretty good. I'm just joking, I was messing up. Alright, yeah, so let's try Hello World, and then... Alright, so Hello World works, obviously. Yeah, so that did make it compile, but then it doesn't work. So, let me see if I can figure out why. Yes. Gotta figure out what's up with that. Yeah. Alright, factorial I. And then we pass it in here. Well, so let's, let me indent this so it's a bit more clear. There we go. Let's just print n then. See, I think it was like that. And then see if that works. Alright, so the number sometimes is null. If it equals 0, return 1. So I don't know why it would ever become null. That's a bit strange. Is there no negative numbers? Could that, like, is it becoming negative for some reason, or I'm not sure. Oops. So let me. Oh no, actually that's printing, because when we print this, let me. Oh my god, alright, actually. So now it's, yeah, figured it out. Okay. And so it does that. Double semicolon on second return, only one on first. Oh, okay. Oh, because it. All right. So do that. All right, and let's see. All right, there we go. Okay, so that is. Oh yeah, okay. So that was. Yeah, because it's variables like that. Okay, that makes sense. That makes sense. It is a bit confusing like that, but I do understand why it is like that. Yeah, so that's 5, 6. Yep. All right, so that is cool. So that all works now. So yeah, also for the compile script, yeah, basically the fix was, let me see, where was it at? So, bit confusing, mostly bugs, yeah. Basically, where was, yeah, so in here, it wasn't in the source. So actually, if we do, no. So, yeah. Basically, this is what I changed, is I made this / source, and so then this should compile all of them, I think. So that was the issue, if you want to fix it. Just getting the base logic out after the wait first, then bug extermination after. Okay, that makes sense. And then, yeah, so then it looks like they all work, so, yeah. Just so you know, if you want to update that, so that works. So I'm assuming you're testing on Windows, probably. So you just use the Windows build script, mostly. So that would probably be why that one doesn't work. So, yeah, because here, yeah, because you do reference the source directly, which you define up there, but I suppose you do not do that in the .sh file, the shell script. Yeah, so this is just compiling all of them. Actually, I kind of want to try to run it through Wine and see what happens. I think that could be quite interesting. Okay, there we go. So build, and there should be all of them. Okay, Windows. Wine me.exe. So, got some wine problems. Right, and let me just disable that and run it again. Okay, so alright, yeah, so that actually works. That's pretty cool. Let me find a bit more thoroughly. Windows demi to here. And then now we have both of those. So let me do the wine demi.exe and let me try it on the Fibonacci. Okay, that works. And then factorial. That works as well. And then hello world obviously works. Yep. Alright, so that's pretty cool. So it does work through Wine as well. Which I assumed it would, but still fun to test. So what is this maths one? So it's just like arithmetic stuff. Yeah, let me X, Y, Z. So can you do something like that? Okay. So it just prints out the first one, it looks like. Yeah, so we need to do it all separate. X, Y, Z. There we go. Okay, so 12, 5, and 47. So let me see if that's actually right. So this is 12, so it should do this one first. So that's 12 minus 5. So we have 7, and then it will do this one next. So 5 times 7, which is 35, and then plus 12. Okay, so that actually did work, so that is cool. So order of operations, that kind of thing, multiplication precedence, whatever you want to call it, does seem to work. Yes, indeed. That's pretty cool. This is pretty cool language. And it actually is a lot faster than I would be expecting for an interpreted TypeScript language. Yeah. So nested function. Oh, so you can do nested functions. That is quite, well, assuming it still works, that is quite interesting. Alright, yeah, so it does look like that works. That is pretty cool. So if you don't call this, then it won't execute that. Yep, alright. That is pretty cool stuff. Yeah, I like that. It is very fast, yes. So, I'm assuming there's not, like, sockets and stuff implemented yet. So you can't do that. So you probably can't make a server with it yet. But that'll probably come at some point, right? One moment. Like, if there was sockets, I'm assuming it would be in the examples. Okay. No sockets. Yeah. I wouldn't expect that. Like, get most of the other stuff. Get it pretty stable before adding that. That makes sense. Yeah, so what else? Multi-return. What is that? So, okay, so let me get rid of the sprint time, because I don't think we need that. Let me try that. So it does 2. So if x is greater than y, so Alright, so it returns y, because it is not. So if we switch this around, then it will return that. Yeah, and then if we do that, and then we don't do anything in here, it's res like that, then it returns 0. Okay, yeah, so that, all the logic seems to work quite well. Is there any other examples that I haven't looked at yet? Let's see. I just fixed the compilation script, so I will push them at some point. Alright, good to hear that. Glad to hear that. Yeah, any other ones? See, nested functions. Let's see. Yeah, so I think I looked at pretty much all of them. It is pretty cool. I will actually give that a star. Yeah. Okay, there we go. It updated. Yeah, this is very cool, and I will definitely be following this. Man, the Windows, the backslash. I can't say I like it. Yeah, not a big fan of Windows. REPL or bypassing a file. Yeah, so that is pretty cool stuff. Oh, here's the syntax file. Alright, for Visual Studio Code, so I'm not going to use that. If I push the changes, there are the for loop and negative number examples. Okay, so, alright, well, when you do push those, I will take a look at those. Negative number, okay. So, let's see. So are you the only contributor to it thus far, and it's just yours, or do you have like a team that you're working with? Because I see you're the only one to make any commits, but I don't know if like you're collaborating in a different way or anything. All right, contributing. Yes, I just want to read through some of this stuff. Table of contents. Only contributor at the moment. Okay, so you did all this yourself. That's pretty cool. I want a team though. Yeah. Okay. Yeah, well, I might, I mean, I don't really know, I'm not very great at JavaScript or TypeScript, but maybe I could learn it a little and try to contribute a little, like, even if it's just bug fix here or there or whatever. Yeah. Like, yeah. This is pretty cool, though, for just yourself. This is quite a bit of stuff. So, very cool. Yeah, so I think probably going to be about done for the day. So I'll be ending the stream soon. So if anybody wants to say anything in chat or whatever, then now is the time to do so. Yeah. Yeah, I'll read through this. So let's see. Yeah, here is the main.ts. So, so front end and runtime. Standard library, okay, interpreter. Changes push. Alright, let me look at that and then I will probably end the stream. 19. Alright, yeah, so let me just forget which one. So fetch. Alright, and now we should have the new stuff, so you can actually look at what is changed. So in the examples, I'm assuming. Let me compile it. Yeah, all. Alright. Okay, and they all seem to work. So, examples. Alright, for loop. Maybe fetch didn't work. Negative numbers and for loops are the only interesting changes. Okay. Yeah. So let me actually, hold. Alright, yeah. I'll just stash because I'm not going to be using them. Yeah, because that was just changing the examples and stuff. Alright, so let me do it now. Fetch, yeah. So I don't use Git very well. So that's all the changes. So let me do the compile.sh. Alright, and oh yeah, it's not dash, it's just all. Okay, and they seem to work, so that is cool. Works now. That's a good change. Quite important as well. Let's look at examples. What? Yeah, so let me actually going to build Linux demi, do it here. Whoops, no, that's not what I meant to do. I meant to copy paste it. There we go. All right, now we have the most up-to-date one, and let's see, for loop. All right, so let me look at the for loop. All right, so it's like C style for loop. Yeah, so that is cool. I like that. So I equals I plus 1, so there's not I plus equals or anything like that, it looks like. We can try that because we have the creator here, but yes, that doesn't work. That is fine, though. Alright, yeah. If I equals 7, print I equals 7. Alright. So it just goes until 10. Alright, so let's look at 7. I equals 7. Alright, cool stuff. Plus equals shouldn't work. Yeah, it does not. Alright, so now negative numbers. Negative numbers. Let's run it first. Alright, so that is cool. Negative numbers. Print -1. Alright, so then I'll just add one. Print negative that. And let's see what it does. Alright, so is it 32-bit limit or it can go beyond that? Okay, so it does that. Yeah. Alright, so it just converts to scientific notation, it looks like. Yeah. I was planning to add strings, which will reverse the string. Oh, okay. Yeah. Oh, negative strings. Okay, I see. I misread. Yeah, negative strings. That's a cool idea, actually. Negative hello world. Yeah, like that, and then it would. That's pretty cool. I would like that. Okay, whoops. Yeah, alright, so that is cool stuff. And you said that was really the only changes, the only major ones at least. A lot of stuff in here was changed, but well, yeah, so this is very cool. Yeah, so good luck and great job. Okay, so I think now I will end the stream though, actually now. Let me just make sure let's see, git status. Alright, yeah, so I did push all that, so all good with that. Anyway, thanks for checking out, really appreciate it. Yes, well, I think it is very cool. Alright, yeah, so and I will be following it as you make changes. Maybe I'll watch it as well so I can see. Let's see. Yeah, just all. That's good. Yeah, so I will definitely follow that. Very cool stuff. Alright, so that's gonna be it for